Okay, now make sure everyone understand from next week. You will be get the two-day meeting, Monday and Tuesday. No meeting for Tech One on Monday. Tech One, we already get too much done. Okay, now, this is really the real job you have to do, to deal with. Only thing what I want you to make sure you know positive using the scope, a meter, and a generator. No problem. Okay? This is a real job here. When you're looking into the circuitry, one thing you have to know, each individual IC, how they will be working. In here, you can see the first thing you can get a U1 164. That means you get a serial data go to pin AB, and they converting into the parallel, okay, at the output QA to QH. If you say you call the function, that function will make it for you. Don't have to be understand what's going on this function, doesn't matter. Only thing is you say you call this function to converting data 5. That means you can get a 1 0 1 0 1 0 1 0. Okay, that's only thing you need to know. Okay, so the first tab and the second tab, they writing the data serial 5. Then they go into input for U2, U2 541, just the buffer. Okay, if the pin 19 pin 10, then whatever at the input will go to the output at this. So now in the program, if you want a pin 119 at the 0, you need to call the function we call enable U2. This function will be doing for you. That means they will be set pin 20, pin 30. So pin output 4 will be 0. So they allow data to go. The first tab guarantee nothing wrong with the output here. Okay? If you pass the first tab and the second tab, so you don't worry about anything here. They will be good. That's number 1 and that's number 2. If you get any question or any confusion, bring it up. I can try to answer to you.
Test 1 and 2 just means that U1 and U2 is okay.
Right. After they pass number 1, number 2, then don't worry about U1 and U2. If some wrong, they must be failed at that 1 or that 2. Okay. Next, I'm talking about EU4. Okay, if you're looking on the data for EU4, EU4 160, that will be a BCD counter. Okay, that means this counter only counting from 0 to 9 and 0. That's a BCD counter. And this counter can be, first thing, they can be clear. Okay, the clear active low. That means pin 1, 0 output must be 0. If you don't know, you can look back into the timing diagram for the U4. Also, U4, you can loading any number from A, B, C, D to output QA, QB, QC, QD. Okay? Then, if this U4 here is the clock control. That means if you apply, you want the clear, you apply pin 1 at the logic 0. They not clear yet until you must be apply the clock signal. Same thing for the load. You can set everything at the A, B, C, D here. And also pin 9 load 0. They not load yet until you must be apply the clock. Okay? Now, if I want to load in number 9, then the data I send it to here have to be number 9. One, 0, 0, 1. And that whatever, we don't care. The thing I did will be go into U5, not U4. So in order to do it, you just call a function serial to parallel data 08. Okay, 09. Then they give it you that one. Okay. So when you get a 10101, now you want to load. If you want to load, that means you want 0 here. Clear have to be 1. Okay. And the data will be go here. 1, 0, 0, 1. In order to load it, we already make the function which say U for load. You call that function. They will be doing for you everything. Okay? In order to get a 1001. When you get the data here, you need to verify. And that data will be go to here. 1, 1, 0, 0, 1. You want to go be here. Then you must be get pin 1 have to be 0. In the function, I call U7A enable, U7A. Then now you can verify. So you have to know how the path, the signal going. So that's why you can able to make a troubleshooting when it fails. Exactly the same at work. At work, you don't have to write a program. Engineering already did it. However, when you run the program, they fail on that number 3, for example. If you don't understand, how can you troubleshoot it? So in here, I just make sure you follow it. If I want pin 1 to be 0, that means I want the data going from input to the output, then pin 1 must be 0. and pin 1 must be 0. They have to go back to here. That means you have to setting PA, PB1, PB2, okay, have to be 0, 1. So pin number 5 will be 0. And that's what we put it in to the function we call enable U7A. Now, if you want to enable here, then you only call the function enable U7B. Okay? So you get anything, okay, on this schematic and do not understand.
Mr. Pham, when you first start talking about the clear and the load on U4, they pin 1 and 9 go back to U3, 10, and 11. I didn't hear you say enable anything.
You're talking about loading, right?
Right. Loading or well, yeah, because for load and clear on U4, pin 1 and pin 9 go back to U3, 10, and 11. And I didn't hear you talk about enabling anything. Yeah, when you were talking about those two.
Okay, now when you try to load it, U1 have to be 1, right?
Right.
And pin 9 must be 0.
Correct.
Okay, so that's why you call the function load U4.
Mm-hmm.
They will be automatically set for you pin 9 to be 0.
So
Pin
it'll
have to be 1.
yeah, okay. So does anything need to be done, I guess, with U3, B, pin 10 and 11?
U3.
U3B.
That's where you're writing to port B to get the output that you want at pins 10.
Right. That
Yeah.
means you have to writing to port B, right? You have to write it to port B. So in order for pin 5 have to be 0.
Right.
Okay? But what I'm saying is, you don't want to write step by step everything.
Mm-hmm.
So that's why I put into the function.
Mm-hmm. Yeah.
And that function I call a load U4.
Okay, gotcha.
Okay? So if you want to enable U7B, then you got just a call enable U7B. They will be set pin 19 to 0. Okay? That means they will be right to port B, pin 1, pin 2 here to make sure pin 6 to be 0. The thing I try to put into the function makes sense to you. Okay? So we don't want to do doing writing step by step by step. If you want it, you have to go into load U4 to see what's going on inside. This is a very, very simple lab. You get a U4, you can testing for clear, you testing for load, you testing for counting. Okay? You get a U5, U5 191 binary counter. You can counting up, you can counting down, you can loading any number. Only thing is you don't have a clear function for 191.
So when you're counting on U5, you manually load 0, 0, 0, 0.
Exactly.
Start your count up instead of using the
Right.
clear.
If you want counting down, you loading 1, 1, 1, 1 and counting down.
Mr. Pham,
Yeah.
I have a little problem with U5, okay?
Okay. Go ahead.
It's on regarding a pin 5 where it control it counting down or counting up.
Okay. 0 counting up. 1 counting down.
Okay, but how does it controls it? Because that coming in pin is from U95.
U95 right here.
Right.
Okay. When you try to clear, that means 0.
Okay.
That means they will be 0, they will be counting up.
Okay.
Okay.
Mhm.
After you counting up, done. Okay. So you can get the two output here, go into the AND gate here, apply the clock to the U9A. They will be toggle. Then
Oh.
now they will be 1. They will be count down
Okay.
automatically.
So once it hit the top, it will automatically switch to counting down.
Exactly.
So you don't have to reset it to count.
Now, after the done for counting up, that means U5 generate the pulse coming out to plug into U9. Now they will be toggle.
Mm-hmm.
What 0, now they go 1.
And then once it count down to 0, then what happened? When
Let's
you count down,
try again. They do it the same thing.
it will automatic. So it just keep counting up and down, up and down.
Exactly.
Okay.
The
So,
thing is when you want to troubleshoot it, you try to get the idea to understand what's going on. Okay? That's why we can troubleshoot it. I've given you the example. When you start counting up, and after you counting up, done, they're supposed to turn this one to logic 1 in order to counting down. However, now they're not counting down. So you have to troubleshoot it looking at pin 5, see what logic. They supposed to be 1, but they not 1. That means either you don't get any the clock going to here, or wiring connection is wrong. Okay, so that's why you can figure out how do we trace them out where it's wrong. This software will be very, very good. That means when you've done for counting up and they not counting down, if you're looking here, you get nothing. So that's why you can using software, generate a loop. They keep running. Then if you're looking at this point 1 here, that means here and here, you can see the signal coming out. And you can tracing signal will be coming out to here, and you're supposed to get the clock going to here. If the people know what to do, when you run it fail, you know right away what to do. A lot of things really need for your guy for troubleshooting. However, I cannot go more. The thing is, the basic you still not done. Okay? So any question regarding into this schematic here. Troubleshooting means you get a right input, but you not get the right output. For example, you loading number 5, 1, 0, 1, 0. Then the output supposed to be 1, 0, 1, 0. If it's not, for example, pin 3 supposed to be 1, then 0. Now, what you need to do, pin 3 coming out from A. You go to take measurement, pin 15. If pin 15 is 1 and pin 3 is not 1, then maybe the load here, you have to take pin 11. They must be 0. Okay? If you get a 0 on 11, you get pin 15 1 and do not get pin 3 1. What else you can do?
Go back further.
Chip is bad. The
Go
chip-
back from pin U515 to what is it? U1?
Now, I try to repeat it. You
No.
want to pin 3 1. Okay? You want a 1 logic 1 here. You using your meter to measure. You get 0. Okay? Then now you have to go to input. That means go here.
Right.
Measure pin 15. Now, my question is, you get 1 here. What can you do?
check the load.
Okay, you say, okay, I go pin 11 here.
Should be 0.
Let's make sure I get
0.
0. Okay, now you get 0. What next?
You get 0 at the load, but you still get 1 on 15, which is wrong.
What do you mean wrong?
Input is correct. 1 is correct.
Input is correct.
Oh, you said you got a 1 there. I'm sorry. I thought, okay, you got a 1 there.
So the other thing should be the clock. Double check the clock.
No. This not controlled by the clock. Load is the second priority.
That's loading. So
Loaded. They don't care.
Could be the
Clock
chip.
or whatever equal.
Then the chip is bad.
Okay, now two things can be happen.
Maybe wire.
Now, in the lab, then you have to deal with the wiring. However, at work, you don't have to do with the wiring. You just say, okay, go ahead and then you find.
You can pull the wire on 15.
Again, I said right now, I'm talking about in the company.
Yeah, in the company, I know what you said before, Mr. Pham, that you're not allowed because the boards are manufactured in a way where you cannot pull the wires.
Exactly.
So you have to check using voltage measurements and that type at the company. But here, you can pull wires and things.
No. So I separate two things, otherwise confusing for the student. Right now, I'm talking about company.
Right,
The company, we don't deal with the wiring.
right.
So when you measure the input, pin A, you get the logic 1. Pin 11 load, you get a 0.
Right.
But do not get pin number 3 at the logic 1. Then you just say, okay, go ahead and change IC U5. That it come up with the end conclusion. Your supervisor, maybe they can ask you, how come you change U5? And you have to prove it. You can say, okay, I measure 15. Pin 15, I get logic 1. I'm load 0. How come the output not 1? Then that to me, you find not working. That is that I'm talking about at work in the company. Now I'm talking about in your lab, okay? That means you have to build by the using the wiring. Who telling me better way to figure out what's wrong? If you're doing in your lab, when you measure at the pin number 3, you get a 0.
You can pull the wire at number 3.
Then what?
Then measure directly on the chip and see what you get.
Perfect. First thing we want to isolate the wire. Okay? That means you just lift it up. And now you measure at pin 3. If you get a logic 1, that will be telling you the wiring from pin 3 go wrong place. And now you can take the wire. I don't want the people after you build the circuitry and try to sit down and take the on off the wire. Okay, who cares? When they fail, then we will do it. That is how to troubleshoot it.
So, Mr. Pham,
Yes, sir.
basically what you just told us is there's 2 ways of doing things. One way is the company way, and one way is the classroom way.
Right.
But the company way is more realistic in how it's done in the real world.
Right. For a company way, you must be follow it. Don't worry about the wiring. Don't try to see the wiring, move the wiring. Cannot. Normally the wiring will be under wire. Okay? You cannot see it anyway.
The only reason we removed the wire is because we're in the class. But if we were at the company, we wouldn't actually do that.
Yeah, you cannot do it.
Okay.
Any question?
Yeah, Mr. Pham, could you please repeat what U2 is doing? I missed that part.
Great one. You too?
Yeah, just yeah. What is yeah?
Okay, now U2 541. If you're looking on the IC data, I already given to you. That's just the buffer. Buffer means this is the input here. Input here. They will be go into the output here. If pin 19 and pin number 1 at the logic 0. That's it, nothing else. Pin 9 logic 1 and pin 11 logic 1. Pin 9 logic 0, pin 11 logic 0, nothing else.
And U7 works the same way.
U7, right, same way, but you can see the difference. U2, they control 8 bits at a time.
Right.
U7, they control only 4 bits separately. They pin 1, U7 control the first 4 bits. And pin 19, they control a second 4 bit. That's easy for the people when they design the circuitry. Sometimes they want only 4 bit buffer. Then they can using 244. But they cannot using 541. 541, 8 bit at a time. Okay, now What else?
At some point, we got to do the 7 segment, right? Because we did the,
No, not yet, not yet.
not yet. Okay.
Yeah, we'll get it done before we move into the 7 segment.
Mr. Farmer, I have another basic question.
Yeah, go ahead.
The numbers that you gave for the chips is the obvious way that we have to follow to understand this kind of circuits. I mean, if you say U1, always we should start pay attention for U1 and then U2, U4.
First thing, the individual, you
Yep.
have to get the understanding.
Okay.
That means, for example, how you add working. You know that to the AND gate. If you get an input 0, output 0. If you don't know, then no way we can teach, you got
Yeah.
you
Yeah.
must know. Like I say, U2. Okay, U2, you get 8-bit in, 8-bit out. They the same 8 pin 1 and 19 0.
Okay.
That's it. Like U5, they can counting up 0 to 15. Or they can counting down 15 to 0. Or they can be loading any number you want it. That coming out from the timing diagram. Try to learn how to read that. When the real technician in the company, you can get something else, but you're looking into the data, you're able to recognize it. Anything now more easier. The thing is you go Google, you type in, they give you everything you need.
Okay. Okay. Thank you.
Yeah, you're welcome. Now, today, I want to help you to finish for the function. Right here. That's what I need you to do until you get part. So, like I say, enable you to. Then I already telling you, you have to write to port B. You see that right here. This is a function definition. You need to write to port B. Then you have to tell me what data here you're supposed to write. Okay? So in the past, I already did it. You say 0, 8, right?
Right. When you do this part, you actually have to go back and forth between the circuits so you can see where everything is going, and then you come back to this.
Right. That means on that one here, okay, so basically you did the enable, okay, let's see, enable E2 right here. That means you have to write this 0. This 0. You get this 0.
Correct.
And basically you already get the table. 0, 0, you get a 0 here, the rest will be 1. So if you change the 0, 1, then the next will be 0, and the rest will be 1. Okay? That will be U7, 1. We call enable. U7, A, when you call enable U7A, they will be writing 01 for you. Okay, so that's why we need you to get this done. Okay, enable 7A 08. Okay, 01. Enable U7B. What for port B? 08. What? Who tell me? Enable U7B.
0x02.
Enable U7B 08
02.
02. Okay, and now we get a function load U4. They get a parameter. That means when you call this function, you can call a load. Okay, U4. And now you want what data? You say 08, 09. They will be loading number 9. Okay, now inside this function, okay, this one okay, nothing. However, what the data you have to write to port B?
0x0b.
Okay, loading for 0x0b. Next, what you have to write to port D?
0x00.
Okay, then you call the function U for clock. So every time you want to loading a data, whatever data, to U4, you just call the function load U4 and you put whatever data in here. They will coming out of the U4. U4 clock, you just get the only system function and clock. Okay, that means instead you typing and clock, okay, then you can using U4 clock to make sure more easier to understand. The thing is, when you want to clear, after you clear, you have to call the clock. If you want to load, after you loading data, you must call the clock. So that's why I using U4 clock. Okay. Now, void clear U4. Clear U4, then what you write to port B?
0x07.
At 07. What you write to port D?
0x00.
Okay, then you call the function U4 clock, and what finally what you write to port D?
0x01.
Basically, when you get this, that means you really understand what's going on when you want to clear output of the U4. Right now, I just given you the key. Make sure you can get through it to part first. Now load U5, same thing. You can load U5 080550, okay? Or you can loading 08A0. You call the function here, okay? And put an put any number you want to load. Okay, what you need to write to port B? Load U5.
0x0f.
Okay, 0x0f. What you write to port D and port D?
0x00 followed by 0x01.
Okay. Night U5 clock. What you need to write port B?
0x03.
Then what night? D.
0x01. 0x00. 0x01.
Right now, I want you to make sure you can part, okay? If you already done everything, then they will be part. Then after that, we can going back. You can asking me what's going on for EU5 clock. Then I can telling you how they working. Why you write 0803, then 0801, 0800, and 0801. Okay, any question regarding into the function? Most of the software, the program, they normally using the function. And that function makes sense for you when you're reading. Like I want to apply the clock to U5, then I call U5 clock. Then now if you want to know what's going on in order to get a U5 clock, then you can go through 0803, 81, 0001, and I will explain to you why you have to write to port B, that number, or port D, that number. You must be understand the job is fix the problem. That is a technician. Okay? That working requires your brain. Okay? Not easy. So that will be a more skilled job. One time you not quite follow it, next time you get a better if you spend the time. Okay? You're working on. Not too many lab. Okay? Next meeting, we'll be talking about a memory. Okay? And how do we testing the memory? And next after that, we can go to the A to D converter, D to A converter. That means cover everything, okay, on the texture. But the measure will be the lab. If you can do the lab, mean you understand. Any question or anything else?
Hey, Mr. Pham, you said at another time you don't want to go into the 7 segment yet, right?
No, not yet.
Okay,
Until we get this test done to part first.
okay, okay.
Go to the 7 segment, that's easy, very simple. And that will be a manual intervention. That means you loading into the U4 number 9, you're looking at the segment they display number 9. You're loading number 5, number 3 on U4, you're looking segment, you see number 3. Okay?
Hey, can I ask you one question, Mr. Pham?
Yeah.
Okay, so basically on this lab 8, you're doing about 3 things. You're using the BCD counter going 0 to 9, and then you're using the binary counter going to 15, and then after you do those, then you do the segment.
Right.
So you're having us count 3 ways: counting with the BCD, counting with the binary, and then counting with the segment.
Right.
Okay, thank you.
Okay, any question? If it's not, I go to the program. You get the version B, okay? For this software, I just change something. First thing, before you get this function here, I call a evaluation. No, now I change it to test validate, okay? And that means inside the function definition, you just change the name for evaluation to test validate, okay? And also what you need, everything. I already make a decoration for you, like serial data, enable U2, enable 7A, and so forth, okay? Only thing you need to typing in the function definition for each one. For example, enable U2. You want to write the function definition. You're looking on the one I just given to you. You write to port B 0x00, for example. That means function definition. Okay? And this one I already given to you, the test number 1. Okay? And also in here, I can put some comments. This test requires following step: call serial data to bit 1, 0x55, call enable U2. Okay, so that will be called test validation, not test evaluation anymore. Okay, then that means you're done with the test number 1. Okay, and now you copy test number 1 to make test number 2. Number 1 and number 2, the difference will be number 2, you change this data to a So on the test number 2, you say, okay, expect data have to be A and A. Don't using that, we don't need that. You're not changing. You don't need to typing again. You don't have to typing that. The thing is nothing change. And now you call the function serial here. Data you want, okay, have to be A and A. And enable or 2. And you verify. That means you can done for that number 2. And you start coding that number 3. Number 4, number 5, number 6, so on. You get a problem. Just get in Zoom with me. That will be help you get the job done quickly. If you don't know how to do what to do, don't do it. You must try to make it clear. Don't waste the time. Okay, any question for coding this program? I don't care you can get the test 1, 3, 4, 5, 6 done or not. But the priority, you have to adding your function definition using the Excel I just showed you. I want to see that first to make sure you get the right function definition.
At the bottom of the program outside the main.
Right. Function definition. You understand the normally when, okay, when you're done, okay, they can tell you end of man right here.
Right.
So after, below that, will be the function definition area. So this one I give it to you completely, just typing in. Okay, and test validate, I already given you everything, just typing in. Only test counting up, I already gave it to you. Okay, counting up, counting down. Okay, now in here, you still have to get void you enable you choose. That means function definition for you choose. Avoid enable you 7A, 7B, I want on off. That function definition will be in. We have to going step by step. Then, after you can get through that, you can run the test 1, 2, 3, 4, 5, 6, whatever. Go to before you counting up. Then we're talking about counting up. Now, you can see test you for counting up. Okay? In here, they can say test title. Okay? And I give it to you step number 1. You need to clear U4 to be 0. Then set U4 pin 1 clear not active to count. So you want to load to 0. Okay? So you want to clear U4. Math data will be 0F. And now you want the data coming out U4, you must enable U7. Then you want to using the loop for 10 times. You say for j equal 1, j less than or equal 10, j plus. First thing you need increment the test number. That means whatever before you call the function, this function, whatever that, now they will be increment total will be 10 times. The thing is they run 10 times. Then you apply the clock. And now if they less than 10, then what else here? Okay. That means when you get up until end of the loop, you done for that function. Okay. Let's see. Now, data here. Counting up here. This is a flow diagram. Okay. Whoever, when you're following this flow diagram, they call a flow chart. And you're able to converting into the coding. Then you're able to be a very good software. Okay. So the first thing you can see, what's going on here. When you get the rectangular here, that means the process. Number one, what you do, you typing that title. Next, you typing map data. Next, you call the function 7a. And then you call a clear. That's just a process telling you what to do. Then now you go to the loop. They say for j equal 0, j less than equal 10, you say j plus plus. If you want to know, you have to open your C++ introduction. Open the part for the for loop, how the for loop will be writing. This just a math. You cannot change. For have to be followed exactly the way they want. Okay, then inside the loop, you say that number plus plus increment that number. Then you call the function for clock, you apply the clock. Now, in here, they say, if j less than 10, no or yet, that means you must be using a if statement. If j less or equal 10. If yet, then you say, okay, I want output to be a j. Otherwise, I want the output to be 0. The thing is when they counting from 0 to 1, j equal 1, q equal, output equal 1. However, when they count up to number 9, then the next output, not number 10, they will be number 0. So that's why you have to using this if statement, if else. Okay. Then also in here another if statement. Is it j equal to 1? No or yet. Okay. If j equal to 1, if it's yet, it's supposed to be here. If it's yet, that means first time you start counting, they're not counting not only U4, they can be related into the other U. That's why we call U3, U4, U10. Peacock. Otherwise, peacock will be equal to U4. Okay? Then that will be done. For general, any more questions? What I want you try to get through the function to make it fast. Try to coding on of the function definition. That's your job for now. So next time, if I see you, okay, I will be asking you. The thing is that's really new to a lot of students. Okay, so any question, anything? Anything confusing, anything you don't know?
Get it done or walk the plank.
Kuba.
That's like in the Navy. They say, get it done or walk the plank.
You cannot done the lab on the tech tool, the lab. You can stay forever. The main thing will be the DLAB. Understand that's their problem. Okay, any question, anything? Make sure next week, Monday, we'll see you guys. You get Monday and Tuesday.
All right, thank you, Mr. Pham.
Okay, well,
Thank
good
you.
night. Good night, everyone.
No, Mr. Pham.
Yeah. So far, I see only Adam really understand when he talk to me. Okay?
He's gonna be an engineer.
Yeah,
Ooh, I hope so.
you will, guarantee. You can understand whatever I teach you here, no big deal. Just take your time. Okay?
All right.
Yeah. Good night.